Okay, so we're going to take a look at the factorial problem again, but this time we're going to actually do it using recursion. Calculate factorial of n using recursion. So what something we want to note, so just by definition, 0 factorial is by definition equal to 1. A 1 factorial is also equal to 1. And then, it's like 6 factorial, that's equal to 6 times 5 factorial. Or in general, I can say that n factorial is equal to n times n minus 1 factorial. Right, so 6 factorial is equal to 6 times 1 less than that factorial. N factorial is equal to n times n minus 1 factorial. We're going to use that inside of our, for the logic of using recursion. So I'm going to, when we create recursive functions, we need to think of two cases. We need to think of the stopping case. When is the problem going to end? So in this case, it's when if n is equal to 1. And at that point, I simply return 1. Else, I'm going to return, I need to, 1 is the easy answer. I'm going to return n times factorial n minus 1. This is going to take a little bit of time for you to grasp, but let's imagine I'm going to calculate 2 factorial. So if I, my main line, I'll say print factorial 2. 2 is going to be sent up. Is n equal to 1? No, it's not. So it's going to come down here. It's going to return 2 times the factorial of 2 minus 1, factorial of 1. I've just called my function again. So it's going to return the value of 2 times this function, but I don't know what that function is. So I can't yet return to line 10 the answer. I know it's going to be 2 times whatever the answer to this function is. So I need to find out the answer to this function first. So I'm sending it 2 minus 1, so I'm sending it 1. I come up, I call the function factorial 1, n is 1. Is n equal to 1? Yes, it is. So it returns the value of 1. This now has a value of 1, so that becomes 1 times 2. And so the factorial of 2 is going to be just 2. Sure. Now what about if I do a 3? What's going on? So I'm going to send up first. I call factorial, sending it 3. So n is equal to 3. Now, is n equal to 1? No, it's not. So it's going to return 2 times, sorry, it's going to return 3 times factorial of n minus 1. Well, that's the factorial of 2. So in other words, it's going to return the answer to factorial 2. Well, what's the factorial of 2? Factorial of 2, I send it up there. 2 is n equal to 1? No, it's not. So it's going to return the answer of, so we know n is equal to 2. So it's going to return 2 times the factorial, right? N is 2. 2 minus 1 is 1. It's going to return 2 times the factorial of 1. Factorial of 1. So all of these things, it's creating this chain of events. It can't find the answer to factorial 3 until it finds the answer to factorial 2. Can't find factorial 2 until it finds out the answer to factorial 1. Factorial of 1, I send in 1 here. Is n equal to 1? Yes, it is. So I've reached the stopping case. It's going to return a value of 1. So factorial of 1 is 1. So now I can return 2 times factorial 1 was 1. So that was going to return to this function here, a 1 there. So now this function can now return 2 times 1. It returns it up to this function here, which is 3 times 2. Now this function of factorial 3 is going to return an answer of 6. And so when I run this, I should put my close brackets, get an answer of 6. All right, so that's the concept of factorial. You might argue, well, why do this instead of just doing the loop like we did in the previous instance? And in this case, I'm not sure that you would want to use factorial, but it's a simple example. But if we start looking at more complicated problems, maybe say, for example, a chess match, which has got all of these different combinations that might exist, recursion recursion functions are useful in solving these more complicated problems.